once you have calculated a t-test statistic, and once you've examined and understood the p-value and examined the critical value, you can make a conclusion, right? We make a decision to reject the null or fail to reject the null based on the previous steps of 4a and 4b. In our case, assuming we had a t-test statistic of 2.10 with a sample size of 500, we would reject the null hypothesis. But with a smaller sample size, we may not have been able to pick up that signal. Again, larger samples provide more information because there tends to be less sampling variability on the sampling distribution. Again, I also recommend that you calculate a confidence interval. For a t-interval, right, you take the point estimate for the population mean, which is our sample mean. You add and subtract t alpha divided by 2 times the standard error. Right? T alpha divided by 2, right, that depends on the sample size. Right? So we use statistical software to usually calculate confidence intervals using a t-distribution. But what's the key point, though, is you interpret this just the same as before. Right? A conventional confidence interval can be viewed as a two-sided t-test. We reject the null if the population mean, we reject the null that the population mean is equal to some claimed value versus that it's not equal to the claimed value at the alpha level, if that t-interval, if it doesn't include that claimed value of the population mean. So if the null is out, then it's in doubt. Keep that in mind. That's our mantra. And with that, we've really concluded the main steps of hypothesis testing using the one-sample t-test. It's similar to the one-sample z-test, but we use the t-distribution as a more realistic model of the sampling distribution.